Hello viewers, in today's class we are going to discuss one important definite integral in which greatest integer function is involved, right? So here we have this integral from 0 to 2 and the greatest integer square root of e raised to x plus 1 dx, right? So here this symbol denotes the greatest integer function, right? And here we have the exponential function, right? So let us start. So here again what we will do, as we have done in our previous videos, that will make use of the method of substitution, right? So here let us take t is equal to square root of e raised to x plus 1, right? So now here we have t minus 1 is equal to square root of e raised to x, taking 1 to the left hand side, and now taking the square, we have e raised to x, right? Okay, now if we take the natural log of both sides, we have log of t minus 1 square is equal to log of e raised to x, and here we have 2 log t minus 1, and here we have x log e, and we know that the natural log of e is 1, so we have 2 times log of t minus 1, that is equal to x, right? So x is 2 times natural log of t minus 1, right? So therefore dx over dt is now equal to 2 over t minus 1, because the derivative of log x is 1 over x, right? And here dx is now equal to 2 dt over t minus 1, right? Okay, so now here we are changing the variable x to t, so let us change the limits accordingly. So here we have x is equal to 0, here we have x is equal to 2, so whenever x is equal to 0, then we can now use this expression here, right? So when x is equal to 0, then we have 0 is equal to 2 times log of t minus 1, so we have log of t minus 1 is equal to 0 over 2, that is 0, and this can be written as log of t minus 1 is equal to log of 1, because log of 1 is equal to 0. So therefore comparing both sides, we have t minus 1 is equal to 1, so t is equal to 2, right? Okay, so when x is 0, then t is equal to 2, and when x is equal to 2, then again we can find out the value of t from this expression. So we have 2 is equal to 2 log t minus 1, and this 2 and 2 get cancelled, so we have 1 is equal to log of t minus 1, so log of t minus 1 is equal to log of e, right? So e is the exponential number because the log of e is equal to 1, right? So now comparing both sides, we have t minus 1 is equal to e, so t is equal to e plus 1, right? So when x is equal to 2, t is equal to e plus 1, and when x is equal to 0, t is equal to 2. So viewers, now our original integral I can be written as I is equal to 0 to 2. So when x is equal to 0, then t is equal to 2, and when x is 2, t is equal to e plus 1, right? And for this greatest integer square root of e raised to x plus 1, we have greatest integer t, and for dx we can write this expression, so we have 2 dt over t minus 1, right? Now we can take 2 outside, so we have 2 to e plus 1, and here we have greatest integer t over t minus 1 dt, right? Okay, so now viewers, here we have to make use of the definition of greatest integer function, which says that when when t lies between, say, 1 and 2, then the value of greatest integer t is equal to 1, right? So we'll make use of this definition, right? So now here we see that t varies from 2 to e plus 1, right? So here we have 2, and e plus 1 lies somewhere here, right? And we know that the value of e, the approximate value of e is 2.71, right? So therefore the approximate value of e plus 1 is 2.71 plus 1, that is equal to 3.71, right? Okay, so viewers, the approximate value of e plus 1 is 3.71, and see, the integer 3 comes after 2, so 3 lies somewhere here, right? Okay, so now between 2 and e plus 1, between 2 and e plus 1, we have the integer 3, so we have to break this integral as a sum of two integrals, right? So one is from 2 to 3, and the other is from 3 to e plus 1. So now I can be written as I1 plus I2, right? And I1 is from 2 to 3, and we have here 2 and greatest integer t over t minus 1 dt, and I2 is from 3 to e plus 1, right? And we have greatest, here we have 2 and greatest integer t over t minus 1 dt, right? So now I1 is given by this integral and I2 is given by this integral, and 3 is the point where we have to break the original integral, right? Now here we'll apply the definition of greatest integer function, which says that, see, here t lies between 2 and 3, so the value of greatest integer t is 2, and here t lies between 3 and e plus 1, right? 3 and e plus 1, and what is e plus 1? e plus 1 is approximately 3.71, so we can write this inequality as this. So t lies between 3 and 3.71, so this implies that the value of greatest integer t is equal to 3, right? Okay, so here we'll substitute 2, and here we'll substitute 3, right? So therefore I1 is equal to 2 times integral from 2 to 3, and we have 2 over t minus 1 dt, and I2 is 2 times integral from 3 to e plus 1, and here we have 3 over t minus 1 dt, right? Now we have to solve I1 and I2, and then we'll add these two integrals. So now viewers, here we have to make use of the result which says that dx over x minus a is equal to the integral of 1 over x minus a is equal to log of x minus a, right? So here we have t minus 1, which is of this form. So therefore I1 is equal to 2 times, and we have log of see here we have this 2, so this factor becomes 4, and we have log of t minus 1, and limits are from 2 to 3, right? And I2 becomes, here this factor becomes 2 3s are 6, and here we have log of t minus 1, and the limits are from 3 to e plus 1, right? Now here we can substitute the limits and we'll take the difference. So we have 4 times log of 3 minus 1 is 2, and 2 minus 1 is 1, so we have log 2 minus log 1, which is simply 4 log 2, because log of 1 is equal to 0, right? And here we have 6 times log of see here if we take t is equal to e plus 1, so we have simply e, and minus log of 3 minus 1 is 2, and see here we have 1, log of e is equal to 1, so we have 1 minus log of 2, so this is 6 ones are 6, 6 minus 6 log 2, and now I is equal to I1 plus I2, and I1 is 4 log 2, and I2 is 6 minus 6 log 2, so 4 log 2 minus 6 log 2 is minus 2 log 2 plus 6, which can be written as 6 minus 2 log 2, right? So viewers, the value of this given integral is given by 6 minus 2 log 2. Now here we can also express this result as 6 times log of e, because log of e is 1, and we have here minus log of 4, right? Because 2 log 2 is log of 2 square, that is log of 4, and here we can write log of e raised to 6 minus log of 4, and this is log of e raised to 6 over 4, right? Because here we have used the property of log, that is a log b is equal to log of b raised to a, right? And here we have used log of a minus log of b is equal to log a over b, right? So either we can use this expression or this expression, right? And here this symbol ln is the natural log, which is log to the base e, right?